Hello everybody and welcome to Handmade Hero, the show where we code a complete game live on stream. We are going to do some sampling fixes today. We were right in the middle of it last week and we didn't really get a chance to finish. So we've got a couple things we got to do, and one of them actually will probably lead us to do something that we have wanted to do for a long time but kind of put off. And it's going to happen. Which is to get rid of the C Runtime Library. Why? Because the only reason, we still link with the C Runtime Library at all, we almost don't use any of it. But if you look at what we actually do use here, and in fact we can go ahead and take a look. It's pretty easy to see. Oops, there we go. So if we look at our build.bat file, what we can see here is that when we're compiling the code, we are still using just a pretty standard link line, right? We don't have, you can see here, I guess one thing I would say is it's a little misleading because normally what happens when you link a program is you're supposed to say the things that you actually want to link with, and you can kind of see us doing that in other places. So for example, you see here when we build the Win32 loader, we've got common linker flags is one of the things that's there. And if you go look at what common linker flags has in it, you can see that common linker flags has all of these excuse me, libs on it, right? And so you might think, well, okay, we can look at common linker flags, and those are the libraries that we're linking with, so there we go, that's what we must use. But that's not actually true. And the reason that it's not actually true is because the C compiler makes some assumptions about what you're probably trying to do. And those assumptions mean that it will automatically link at least two libraries usually that you didn't ask for. One is kernel 32, and you'll notice on here kernel 32 is not on this link line, right? Yet if we actually run depends, which I don't actually know if we have depends on this machine or not yet. Do we have depends on this machine? We had it on the other machine that we used to use. But I don't see it on this one. Yeah, I don't see depends on this one at all. Let's just go ahead and download it because I think we want it. Depends. It was 64-bit. So if I grab this guy here, 226 for x64, and we'll just go ahead and grab that out here. So we'll have it. There we go. If we go ahead and run this, we can ask about what we're actually linking with. And we did this a long time ago on Handmade Hero, but it was way at the beginning. So it's something that's kind of ancient history now because we only did it just very briefly at the start to take a look at how the linking was working. But if we take a look here on Win32handmade.exe and I open this up, hopefully, assuming that it works okay, who knows what this is talking about now. Although, the modern linking environment of Windows, which is absolutely disgusting and horrendous, you can still, if you collapse this stuff, see the actual libraries we depend on. And what you can see here is kernel 32 is there. And it's always going to be there unless you do some really weird, fancy footwork. There's actually some ways you can not use it. But as you've seen me do, in Windows you can use a thing called getProcAddress to get the address of a particular function in Windows. And in order to do that, you need to have the function load library and the function getProcAddress, because you need to be able to load library, the thing you want to load, the place you want to get the function from, and you need to call getProcAddress to get it, right? So you need those two things. Well, in order to get those two functions, they have to come from somewhere, and you can't use load library and getProcAddress to get them because those are the ones you need to get functions. So kernel 32 is the minimum requirement to link with on Windows if you want to then link with everything else, right? So we don't have to link with any of these DLLs on the command line. We could load them and then link with them dynamically at runtime if we want to. And in fact, we already do that with a bunch of things in OpenGL just because the base OpenGL lib doesn't have a bunch of the functions in it that we want. But we could also do that with all of these. So for example, winmmdll, we use time begin period from that. If we didn't want to link with winmm.lib anymore in the command line, we could just make a call in there and get that function out, right? We could do that. And then we wouldn't see this on our depends anymore. We would still sort of depend on it because we do get proc address on it, but we could gracefully handle failure. For some reason, winmm.dll wasn't there, we could just not call time begin period and run as normal, and we'd probably still be fine, right? So this is just giving us a little bit of perspective on what we're linking with, but we don't have to link with any of these except kernel32, which we would need for get proc address and load library, so that we could link with everything else dynamically instead of sort of more statically like we're doing here. It's still not statically linking because we are still using the dynamic link library, but it's static linking in the sense that we link in hard bound positions that the compiler generates to link with these libraries using the libs that are listed there. And so it creates this automatic dependency where our executable won't even get to our first line of main if those DLLs weren't on the system. So if for some reason OpenGL wasn't on the system, for example, we wouldn't even get to our first line of main. We'd just get a linker error from Windows that basically says, hey, you don't actually have the DLLs that your like it's not really a manifest, but that your executable says that it needed, right? So you can still then do it if you want to get rid of kernel32 as well and have nothing here. It's just not really recommended. And basically what you do is you do the same thing the kernel32 lib would do to get the address of where the kernel actually is. You have to use some knowledge about how the stack is set up upon entry into your program to like go grab, no, I shouldn't say the stack, but the segments and stuff are set up in order to go grab the address of certain tables you can use to jump to things like get proc address. So you still can do it, it's just probably not a very good idea, and you always know kernel32.dll will be on the system, so there's really no reason not to link to it, right? So anyway, that's currently what we're doing here. So you can see that, well, okay, there's one thing that we're linking to that really isn't quite right, you know, that we didn't specify here, but it's added. So that's added because it pretty much knows any program linked on Windows, unless you're doing something really crazy, is going to link with kernel32.lib, right? I mean, that's just a given. You kind of need it unless you're doing some crazy gyrations to avoid it. Everything else you may not need. If you never call anything in any of these libraries, you wouldn't need to link with them. And also, like I just said, you could choose to use get proc address link with them instead if you'd like. So you have a lot of options of not linking with these. So kernel32 is really the only one that it knows, and so it includes that one implicitly. So we don't actually have to specify that here. You can see if we look for kernel32, right, it's not there. And that's because it just shoves that one in the link line automatically. Now, there's another thing it shoves in the link line automatically. And that something is not actually shown in depends. You noticed it wasn't there because it's actually completely statically compiled in. What is that? That's the C Runtime Library. We've talked about it before. And what's happening there is when we link this line right here, so you see this -mtd, we have told the compiler we would like to statically link with the C Runtime Library using this switch, and it is automatically adding that lib to our command line. So if we wanted to get rid of the C Runtime Library, right, we could, but we need the switches to do it. So we need to affirmatively, instead of, all this does, we could get rid of this right now, in fact, if we did. We would probably still compile just fine. And so you can see there we go. So without the -mtd, it's actually still totally fine, and we're not specifying any other -m flags here, as you can see. But what will happen then is we'll simply just get a different flavor of C Runtime Library, but it's still going to silently link the C Runtime Library in, right? So if we take a look in here, and I look at that Win32 Handmade again with depends this time, let me go ahead and make a, oops, that's not what I wanted. Let me go ahead and make a an open with here. Can I do open with? I can't. Why is there no open with? Usually there's a little open with. All right, well, I guess I can't do it that way. I guess I have to launch depends first. There we go. So if I come in here and I drag this guy back out, this is now linked without that -mtd switch, right? Yes, thank you so much. So if we take a look at what we've got in here now, Oh, this actually looks like it still did link statically, so I don't... Well, it may not have. Did it or didn't it? I'm not sure. It looks like it still did link statically. So I don't see... It should list... It should list... Oops. It should list a runtime library here if we were linking dependently to it. So let me actually try to provoke it into doing that. I don't know if we have any other switches here that would disable that. I don't think we do, though. Let's take a look at linker switch for dynamic MSV CRT minus MD. Let's try that. There we go. And now if I refresh this here, I'm just hoping to get the dynamically linked version for you so you can take a look at it. There we go. So you can see here, if I take out that switch that says, please compile the C Runtime Library directly into my executable, basically copy all of the stuff that we need directly in there, it will go ahead and link dynamically to one. So now it'll try to look for one, right? And that you can see has added a new dependency. I won't belabor that point too much. You can see it happen. This is actually the thing that happens when you see people need to install the Visual C Runtime as an installer when they ship their executable. That's because they did this. If they had linked statically with it, they wouldn't need to run that installer, right? Now, there's reasons sometimes you can't link statically with it that have to do with memory allocation and shared libraries. I don't even want to go into that stuff right now. It's a whole gigantic mess. Yet another gigantic Microsoft puke fest. But what is important to remember here is the part I was trying to demonstrate, that no matter what we specify here, it doesn't really matter what we specify here. We're going to get some C Runtime Library one way or the other. All we were doing is passing the right switches to make sure that it wasn't dynamic. But we're still using their library. We're just having it copy it in and build it directly into our app to eliminate possible compatibility concerns that would arise by shipping without that, right? But I actually want to use all our own code and only call functions that we absolutely have to. That, you know, that's one of the whole points of Handmade Heroes, to show how to build everything, and we more or less have. But there's one or two things that we haven't built ourselves that we're still calling, and they're basically math routines. So what I want to do now, that we kind of did that little diversion there, is I want to just show you what I mean by that by actually asking to get rid of the C Runtime Library. So for example, if I say get rid of C Runtime Library switch, or no C Runtime Library switch, MSVC, we should be able to find a thing that says, you know, here's how to not link with the C Runtime Library. That's actually not it, so I'm not sure why it brought up this page, unless this page has a link to it on there, because it's actually not a -m flag, I don't think. Let's see here. Yeah, none of this is what we wanted. These, again, are, like I just said, these are the things that choose what flavor you want. So you can have debug or release, and you can have static or dynamic. So like the MD and MDD are the DLL versions, but you know, release or debug. And then MT and MTD are like release and debug versions of the C Runtime Library that are linked in statically. But there's actually a linker switch that's like no C Runtime Library, and that's the one I wanted to show you. I'm not sure why it didn't come up on the search, so I got to go hunting for it. But that's what we want. Let's see here. What else could I say? No CRT Visual C++ linker switch. There it is. This is the one I wanted. So this switch goes to the linker, and essentially what it does is it says, hey, if you know you were gonna put extra stuff on that line that you thought I wanted, just how about you don't? That way it won't specify things like kernel 32 or the C Runtime Library, and then it will force us to include them on our link line ourselves. And then what we can do is just not include them on the link line, and then we won't build them into our app. And that also means that it will give us a link time error for any function that we did not implement that we were still calling, which allows us to know what we still depend on, right? Like right now, we don't even know what we call on the C Runtime Library because it's getting silently linked in without our request. So if I go ahead and grab this no default lib as a start, what I can do is inside the common linker flags here, I can place it. Now, I'm not quite going to do it in the common linker flags just yet. What I'm going to do instead is I'm going to copy some of these flags down because the Win32 handmade part, for example, might be able to be made free of the C Runtime Library fairly easily, for example. And so we might want to do that one first. But anyway, after the link flag, if I go ahead and put no default lib here, oops. That was funny. Copied kind of more than I wanted there. If I go ahead and put no default lib there, and then I take this minus mtd part out and add it just to here, right? So just to our compiler flags for the game code, which is actually using the C Runtime Library potentially. I'm going to kind of split the difference there, right? So now we won't have that. These will actually be parts that are common and go from there. So now if I build, what we should see is any place that I was calling a function that was relying on one of those implicit libraries in the Win32 portion. Now, not this, because remember, this one doesn't have no default lib. So Handmade Heroes DLL that has all our game code, that can still call any default library thing. It can call anything in kernel 32. It can call anything in the C Runtime Library if it wanted to, right? And it would still link just fine. But now the Win32 startup code and the OpenGL part, that part that we build as a separate piece, that is now forced to only link with itself and things we manually specify, right? So now we can see here unresolved external symbol errors for everything that we didn't do, right? So all the things that we didn't do here are there. So luckily, if you look at what all of these show, they're all kernel 32 things, right? And so the fact that they're all kernel 32 things means a lot of our troubles have nothing to do with the C Runtime Library, right? We can just add kernel32.lib to it, and off we go, right? When we then compile for our Win32 handmade stuff, we're left with only some very small problems, right? Some very, very simple things here. What are these things? Well, these are things that are actually, I really wish compilers didn't do them. They drive me nuts. But it's a growing trend, a growing, extremely annoying trend, actually, in compiler development, which is that every time they go to compile a program, they have certain patterns that they look for or places in the code where they will call a function from their own C Runtime Library without your permission or acknowledgement, and just expect to have it linked in later. So they basically force the use of their C Runtime Library because the compiler itself is now technically incapable of actually outputting code that runs on its own. It's actually inexorably linked to its own C Runtime Library. So like Microsoft's compiler literally can't produce code that just runs. It can only produce code that runs with its C Runtime Library. Now, that may sound like there's no way to do it, but there is, because all we actually have to do to sort of get around this problem is A, set some compiler switches that make it much less likely that it will generate those functions, and then B, for the functions that it still does generate that you can't get around, put in versions of those functions into our code that we can then use to pretend that we're linking with the C Runtime Library, even though we actually aren't. So we'll basically stub them out, and then the C Runtime Library is gone. Now we can do that actually pretty easily with here, because what you can see is if you look at these functions, what we've got, there's only two that actually do work. So here we've got GS handler check, check stack, security check cookie, and security cookie, right? Those are all just stupid stack checking security nonsense that Microsoft puts in there because they think they're creating something that's more secure. Now, if you've ever paid attention to how often Windows gets hacked, you would know that it's not any more secure, but hey, they wanted to feel like they were doing something. So we can actually turn some of those off. Now, check stack is not quite that. Check stack is actually a useful function, at least if I'm remembering which one of these are which. I've replaced these so long ago that I can't quite remember. But check stack is actually required to probe the stack when the stack is built into chunks, and we can talk about what that does a little bit later. But we can actually get rid of it in a separate way, because it's for doing something that really doesn't super need to be done anymore now that computers have infinite memory. So you can also kind of ignore that one as well, but we'll talk about what all of them means. That will leave us with just two functions that are not security and not stack probe based, which is memset and float used. Now, memset is just used to clear memory, right? And so that's a pretty easy thing for us to write our own version of. And in fact, we don't call it ourselves anywhere. We use our own zeroing function. So all we really have to do to fix the memset problem is provide our own function that clears memory, and that will do it, right? Similarly, float used is actually just there as sort of a really weird. It's not a function, first of all. It's actually just a variable. It's like a global, right? All it is used for is to pull in some floating point stuff from the C Runtime Library as necessary. I believe it's my vague recollection, it's been a really long time, is that it's there to let the C Runtime Library know it should set up the FPU state or something, I think, at the beginning. It's really kind of irrelevant, and we don't really care about it. So all we actually have to do there for the unresolved symbol float used is just define our own float used that gets rid of the undefined external symbol, but we don't actually have to do anything. It's not a function. We just have to put a little stub value there. That's it, right? So this is actually pretty easy to deal with, right? Very, very easy to deal with. And in fact, we can do it right now and go from there. So for example, the ones that are relatively easy to use, the GS handler and the check stack and the security check cookie, security cookie, those we can get rid of really quickly. And I'm going to point you to something that is by far, rather than, you saw how I just had to search through the MSDN for that, and I kind of know what I was looking for, right, or whatever, so it was a little easier. You might ask, is there an easier way to do that? There actually is, and it's thanks to Martin's, if I remember correctly. He actually put a post on Handmade Network that grabs all of these things you want and puts them into one. And let me try to point you to it. We'll try to get the actual address up here. Remove C Runtime Library. And this is absolutely fabulous. I go back and look at this myself anytime I want to do this, in fact, because it's literally like he has put every last thing that you typically had to go through and you had to hunt through MSDN to find it all. He put it all in one place, and he walks you through it bit by bit, actually, right? So you can kind of see here everything in this post I would highly recommend reading. I'm not going to go through the whole thing right now because I don't actually need to. But you should read this whole thing, right? And he talks to, here is him talking about exactly the thing we just did, for example. So that will jog your memory. And then he's got like all the rest of the switches in here as well. So if we take a look down, let me try to get to the section that I'm actually was interested in. So you can see here. So there's a bunch of features that go in right there. Here you go. Allocating large arrays or structures on the stack greater than 4K, right? So what happens here, you can see he's got a great example as well, which is this inside Win main CRT start at the beginning. He shows the example of making something that's like larger than 4K. Now, why does larger than 4K matter? Well, the reason that larger than 4K actually matters is because in the when the C compiler is actually creating your code, you've seen me do a bunch of memory stuff where I allocate memory, and then we use the memory and whatever, and we reuse the memory and all this stuff, right? So we do a bunch of manual memory management. And so the reason that we don't rely on anything in the C Runtime Library for memory management is because we did it all ourselves, and you saw us do it. So that's why that doesn't happen. But there's one piece of memory we haven't been managing ourselves that's been implicit the entire time, right? And that is the program stack. So whenever we call a function, there's these local variables in there, right? Well, those local variables have to live somewhere. They have to live in memory somewhere. We didn't allocate it. In fact, the compiler doesn't give us the option to. I wish it did. but it doesn't give us the option to manage our own stack. That's really not on the table. So, as a result, what you have to remember is every last local variable you ever define in a function, as well as the implicit local variables in the function, like saved registers during calls to other functions and that sort of thing, and the stack pointer, all that stuff. That stuff is all getting stored in memory the compiler is allocating, right? So when you start your program, you actually, and compiler is allocating is not quite the right term. It's not like it's got a memory allocator in there per se, but it's memory the compiler is responsible for having allocated. So the compiler has to have generated something that allows this to work properly, right? So how does this actually work? Well, because in the old days memory was expensive, right? And you didn't have very much of it. The way that this is typically done is by allocating what are called guard pages and then having faults on guard pages produce more memory. So what happens is the compiler will structure your code such that at the beginning of the program, your stack, which is actually, I believe, prepared by Windows initially, if I'm not very much in error. In fact, I'm not in error. When you create a thread in Windows, you actually give it stack size that happens at the beginning. So the initial thread that you get created in Windows is going to have a particular stack size associated with it. And what's going to happen is your program is going to reserve that memory. So it's going to say, hey, I'm going to potentially use this much memory here. But rather than actually allocate it as used, what it will instead do is just say, well, I'm going to reserve a range of memory that I could use, but I'm only going to allocate the first little bit of it. And then what I'm going to do is, as I use it, if I find myself going into the part of it that I haven't allocated yet, I will then allocate that part. So it kind of dynamically grows the allocation and commits it into actual Windows managed memory rather than just being a chunk that would be reserved to eventually use as it goes. It does this oftentimes in 4K pages. Why? Because Windows manage memory in 4K pages. That's the size of a page of virtual memory. So you start out with a page of, say, 4K, and as you use more of that and go into the next 4K, it allocates that next 4K for you to use. So your stack kind of grows and adds pages onto the end as necessary, right? Well, if you were to touch memory more than 4K away from the end of the page, then you would actually fault, because the guard page is just one page at the end of the stack. So in a function, any function, that has more than 4K of local variable store declared, which you can see Martin has created here. He's created an entire 4K variable, which means that this function takes 4K plus the IP pointer storage, the register storage, all that stuff, right? So there's a little bit of overhead there. So this uses more than a 4K page. What it will do is it calls a function right here called checkstack. And what that function does is it will probe the stack in 4K jumps, hitting those guard pages one after the other, making sure that however many 4K pages this thing used in toto for its stack, it will probe out there, pulling in those pages. So that way you won't write past it as you actually use your stuff, right? It's a very simple concept. It's antiquated and weird and stupid, and we don't need it anymore, but it was very, very logical and efficient at the time that it was created, right? So that's what checkstack does, is it's actually a probe that pings out in 4K steps, pulling in those pages, and pulling them in is the wrong word, allocating them basically, by hitting the guard pages, right? That's how that works. So, how does Martins recommend getting around this? He recommends getting around this a very clever way. Because one way we could have gotten around it, right, is to write the checkstack function. Because we could do that. And I'd done that in the past, actually. Granny has some stuff that ships without the C Runtime Library way back in the day. We just implemented the checkstack function. So I had my own version of checkstack that I'd link in that does the 4K probe. That's just what I did, right? But Martin's is like, well, why bother, right? We don't really need that pattern of stack allocation, right? So instead what it could do is just tell us, give us a large stack, right? So what it says here, for example, is let's just ask for a 1 megabyte stack, right? Let's just ask for a megabyte stack completely reserved. So instead of, asking for a 1 megabyte stack and reserving a 4K stack, right? That we then have to constantly reserve, just allocate a megabyte and reserve the megabyte. It's a megabyte, people. Like, no one will notice. Your web browser to display this page of Martin's telling you about reserving a stack of 1 megabyte is taking hundreds of megabytes just to display it, right? So it's irrelevant. So what you can really do is just go, how much stack does my program actually use? Instead of telling Windows to reserve that much stack and then do these little tiny increments just in case so we can save some memory, forget it. Let's just allocate it in a big block and reserve it and be done, right? So that's what Martin suggests here, and he tells you exactly what switches to use, and it's a great idea, and it's exactly what we should do, right? So the first one we want is this one right here, and that is, again, telling the linker, hey, when you tell Windows what to do with our stack, tell them reserve a megabyte and actually commit the megabyte, right? Don't reserve a megabyte and commit a little tiny bit and then bit, right? With guard pages. Just do the whole thing, and then it's good, right? So that's what we go. Let's put that in here. So I'm going to go ahead and say in common linker flags, because we can, even though we're not removing the C Runtime Library from our regular code yet, this is something we will want to do. So I'll go ahead and put that in here. So here's the stack part. And again, we may find that if we blow out the stack, if we have some weird recursive functions or some big functions, these can just be increased, right? 1 megabyte, no one will miss it these days. 10 megabytes, no one would miss that either. 100 megabytes, probably no one would even miss that. That's how much largesse there is. So if you want to have some giant functions with giant variables, we could probably expand this and get away with that just fine. We'll start with this, and if we crash on stack headroom, then we can fix it at that time. But these aren't magic constants, they're just the amount you wanted to reserve. So if we just increase them, we should be able to get more memory pretty much directly, right? Okay. So if we go ahead and compile this now, we will still have a problem because we haven't told it not to insert these things yet. All this does is it tells the linker to give us that reserved part. But the compiler still thinks it needs to do this. So the other flag that he says is gs- and gs 9999999, which are telling it basically, hey, look, we're going to give you a giant stack. Stop worrying about it. You don't need to insert all these calls, right? I don't actually remember what the gs999 does, so I want to just quickly look that one up again so I can tell you what it means exactly. It's been a long time since I've looked at any of these, but I'm going to go ahead and put those on here. And now when we compile, in theory, both of our things should not have any of those, right? And you can see that they don't. So now we're down to just the mem set, like I was saying, and the float used. So gs- is the one that gets rid of the those stupid security cookie nonsenses. So if I just have that one on, you can see that it's only check stack, the stack probe that's there. So the gs999 is the one that tells you, hey, you've got plenty of room, don't insert the stack checking. I don't know just what the 99999 part is, though. I don't know if that's just like the maximum. So I just want to look up so I can recall what that actually does there. So see if I can find it here. Visual Studio stack switches. No, come on. Compiler options. Come on, folks. well, there it is. Control stack checking calls. G-size option is an advanced feature. Stack probe is sequence right. We just talked about what that was. The default value of size is the size of one page. Okay. So basically, this number is just telling you, here is the size of a function's stack footprint needs to be in order for you to think you have to probe. So I guess 9999 was just the value Martins chose of like, hey, look, no function's going to ever have something that many bytes of stack anyway, so that'll just disable it, right? So, but if you wanted to be cheekier about it, you could actually specify, oh, anything that's bigger than 32K, I want it to still do a stack probe. Well, that you could do, right? You'd pass that value there. So that's all that is. Sorry, I just wanted to, I could not remember what you were actually passing here in terms of a real value. So what it is the size of the stack for that individual function that it has to exceed before it inserts the check stack call at the head. All right. So that just leaves us with memset and float used, right? So memset and float used are just two things that we can reproduce ourselves. And one of the things we can do, there's a couple of different ways we can do this. But the easiest way to do this is to actually just look at the C Runtime Library, which I hope we actually have installed because I think I tried to. But I remember the new Visual Studio installer is like even worse than the old Visual Studio installer, which is a temp. I know they have a team at Visual Studio that works on making the installer worse with every version, and that team is one of the best teams at Microsoft. So they do some amazing work. The installer now is probably one of the worst things that I've ever seen, and so that's where, if you're wondering why Windows isn't getting any better, it's because they took all of the talent off of Windows and they put it onto making the Visual Studio installer be extremely large and error-prone, buggy, and do a lot of things that you don't want it to do. And just version after version, they really knock it out of the park. So good job, guys, on that. Anyway, what we wanted to do here is go take a look at our dummy project and see if we can get it to show us the source code for these things. Because that way we can see exactly what the compiler actually thinks we should be doing, right? In other words, the compiler is generating this code, expecting the C Runtime Library to have that code supplied. We are trying to just basically copy whatever the specification is for it and implement one ourselves. So I don't know if this will work because I don't know if we have that available. But we're going to try, right? So, okay, good. So we can see exactly how it's defining memset, right? The exact code that it's using to define memset is this, right? So we're going to go ahead and pull that out here into a special function. What I'm going to do, now this may seem weird. In fact, maybe I should kind of do it. I'm trying to think of how I should show you what's going to happen here. Let me kind of try to do it the whole way through. So for starters, if I was to go through and place this in Win32 Handmade, right, which might make some sense at the outset, remember we would probably want to put this in a shared file because it's going to be used by both people, because both the compiler will generate memset calls in both our DLL and in our executable, right? But anyway, inside the memset call, let me get rid of this stuff here. Those are just some static code analysis markup stuff that they do there. Here's what the memset call is supposed to look like. That's the function signature it was expecting. So let's suppose I supply one of these memset calls here, right? Because I'm like, well, I know that it wants this memset call, so if I just supply it here, it should be able to get it. And what's better is, well, I can implement a memset call. Not that difficult, right? I'll just take a target pointer and I'll set it to equal the destination that it said, right? And then I'll just take that size and while the size function, while I still have bytes to clear, right? I will go ahead and write those bytes as part of the memset. Now, it's weird that this takes an int, but I guess that's just the standard C Runtime Library definition from it. Because we all know that memset only sets the byte values as it goes. It doesn't write 32-bit values, and an int is a 32-bit value. So really what we're talking about here is a cast, effectively, to this value. So, you know, we have to convert it to something that we can write value-wise there. So I'm just going to assume that we can use the value directly and that we won't sign extend it. Again, since we're only ever going to use this to clear to 0, I think, it probably doesn't matter. But either way, I'm going to do it that way in case it was expecting it to not sign extend or who knows what, or sign truncate, I should say. So anyway, we're going to go ahead and grab that value out. We're going to look at the size, and we're going to keep going. We're going to romp over the memory that it gives us with that value until we're done, right? So we have a memset function. But what you'll notice is now when I compile it, it's not gonna help, right? The reason it's not gonna help is because the compiler has sort of reserved the concept that this memset function is an intrinsic, right? So it's actually, it knows that it wants the C Runtime Library version, and we haven't given it the C Runtime Library version, so it's very upset with us about this, right? So the question is, what do we do now? Well, for starters, we do have one problem, which is the memset function here is not defined as a C function, which it wants to be, right? So technically, we want this to be in an extern C because the memset is supposed to be in the C runtime library that's not in the C++ runtime library. So it's supposed to actually be an extern, it's just a C function, not a C++ function that gets name mangled and all that sort of stuff, right? But it already had cdecl on it, which means that for all intents and purposes, that just automatically happened, right? So this will, again, not really help us get anywhere. I just wanted to point out that that's technically supposed to be the case, right? But this right here, there is no other part of C that we care about for this, for the function signature. So even though extern C would have made the function compile as, you know, as if it was being included from a C thing or whatever, it doesn't matter. The cdecl is the only part we care about, which is the way that the function is mangled and called. So how do we actually get this memset intrinsic to be linked? Well, it turns out we can issue a pragma that lets the compiler know that this is the function that it's looking for, right? Let me see right here if this shows us in there. This is not exactly what I was looking for. And neither is that. You can see these here. This is the thing we just implemented, right? Well, point being, what we need to use is this pragma intrinsic here that lets it know that the intrinsic are, that this intrinsic is something that we're actually going to define. So in my recollection anyway, we still need this pragma intrinsic. I don't think it's actually still going to be enough because there's another step that I think you usually have to do. But point being, if we specify this here, like so, I believe that that is required as part of it. But like I said, I don't think it actually works. The reason I don't think it actually works is because I think there's one more step, if I remember correctly, when I had to do this originally, that you have to do. I don't really remember why you had to do it. I shouldn't say remember. I never really quite figured out why, meaning I don't know why the compiler actually cared that it was done this way, because I couldn't figure out any logical reason for it, but maybe there was one. I don't know. So what I had to do in here anyway, and I'm pretty sure, yeah, you can't, no placement of the intrinsic function helps you, if I remember correctly. Yeah. If I remember correctly, there was no way to actually get it to do it here. That's what I remember anyway. What I actually had to do to get the compiler to be okay with me defining my memset is it had to be in a separate file that was compiled as C. That's just, I do not know why it felt like that was important, because it should only really need the code for it, but it must have some kind of way that it's doing something important there. I don't know. So I'm going to make a handmade MSVC function file, it's going to be straight C, and I'm going to put it in there, like so. Now, when I compile, of course, that function isn't being included anywhere, and that's by design, so we're not going to have the memset. But what I'm going to do is I'm going to go into our build, and then in here where we're actually doing it, I'm going to specify, in addition to the Win32 Handmade, I'm going to go ahead and specify this file as well. So in Handmade code, we've got the Handmade MSVC, which is just a stub for if you're compiling with the Microsoft Visual Studio compiler, you need this thing, right? And then when you actually do it, I think you can get this thing to work. Now that's just what I remember, but you know, don't quote me on that, because I don't actually remember the way in which you had to make this happen, but I'm pretty sure that was it. Cannot be defined. Of course, I've never done it on this compiler either. This was only on 2012, so I could be... how do I convince you? I feel like that's correct. What don't you like? I remember this being extremely annoying when I had to do it as well. So, Martins must have solved this for us as well, right? I could go look at my code to see how I did it. It just was a trial and error process is all I remember. No, that's for other stuff. So this is what I tried to do. Is exactly what Martins was doing as well, which doesn't bode well. I hope this is not a thing that happened that means you can't do it now. That would be really bad. Oh, that's why. I just had it wrong. I put intrinsic here, not pragma function. Okay, sorry, my bad. Since this is a separate file now, I can't be using U8 anymore, but that's fine. Okay. Yeah, I forgot. Sorry, it's not pragma intrinsic, it's pragma function. That's my bad. So, okay, off we go. So why memset returns the destination, I don't know. I didn't even realize that it did, I don't think. But, you know, it does. So there you go. All right. So I believe we are good to go on that front now, right? And so, yes, we've gotten to the point where we now have the memset replaced. And then float used, again, is just something that we should be able to... again, you can just go look at Martins because he's got all this down, but I'm just kind of showing you the steps that you would have gone through to do it yourself. I feel like we should be able to find float used somewhere in the math libraries. How come, don't you have to be able to call that? So I'm going to go ahead and look. If I go into the definition here, this is in VC runtime string. So I'm going to go ahead and take a look at the path to that. I want find in files. Where did that go? Does anyone know where that went? Did it not used to be here? There it is. They just moved it out into its own submenu. So I want to go ahead and see if we can find this. This is not, yeah, so that's not the C Runtime Library. Those are just the header files for the C Runtime Library. So I'm going to go ahead and see if I can find if it installed the C Runtime Library, so we can look, we can just grep the source code ourselves, right? So let's go ahead and do find in files. Can this, no. Is there a reason why it won't let me actually? All right, well, that's fine. We'll just do it the other way. So I'm just going to paste this in here. I want to see if it's got the source code. So it looks like it sort of does anyway. I mean, here's the Crt Source Directory. So what I'm going to do is I'm just going to take that source directory. I'm just going to ask Visual Studio if it can just find me. Oh, whoops. No wonder. I was pasting that in the wrong area. There we go. I'm just going to look if it can find any reference to float used itself. Because if it can, then I can look at it. So here are the results that it gave me. You can see one there. You can see one here. And one here. They're all in the same file. So that pretty much gives us exactly what we wanted. There's that definition of it. Again, we don't really know what Microsoft plans to do with this value. We just know that it really wants to pull it in. So we should just be able to leave it there. And we don't need to extern see it. We can just leave it as int float used, I believe. Now, it's a very strange declaration pattern, to be honest with you. I don't even recognize that. How it's, why it's set up that way. I don't even know what that is implicitly meaning. If we have literally this, I don't think that would compile, would it? Yeah, it just seems kind of weird. Yeah, I don't know. So I would just write it like this, and I believe that's sufficient. And there we go. So now we've got the C Runtime Library basically completely out. There is no more C Runtime Library in our Win32 portion. And we've got the WinMain CRT startup situation. So let's talk about that a little bit here. So if you take a look in here where we started out, do you see how we've got a WinMain, right? For the entire time we've been programming, we've been starting at WinMain. And one of the things about WinMain is that we can't actually, that WinMain actually isn't an entry point to your program if you're actually getting called directly from the operating system. What's actually happening there is that the linker, when it builds your executable, because it assumes that the C Runtime Library is being linked in, it actually calls a secret function that you don't know about called WinMain CRT Startup, this one right here, that sets up the C Runtime Library stuff first, then calls your WinMain. So this WinMain is actually only a prototype that is created by the C Runtime Library. It doesn't have anything to do with Windows. It's the C Runtime Library that defines that function. WinMain CRT Startup is actually what's been getting called this whole time when our program starts, and we just didn't know about it, right? So if you take a look in here, if I go to definition of, well, let's do it the same way we used to. So if we take a look at these entry points here, here we go. Just scanning through. So you can see here there's like a bunch of stuff that it's doing. So main CRT startup. Let's take a look here. This is really annoying. I should just step into this actually. Can we build this program? This way I can show it to you. There we go. So now in theory, I can step into this, right? Here's our win main. See, it looks exactly like the win main that we had before. And what I want to do is I want to see the external code, right? I would like to see what that actual code is that's higher up on the stack, although it looks like it doesn't really want to show it to me. But hopefully I can coerce it to do that by getting to our return statement. And then if I put in here the disassembly, here we go. There's our ret. So this will hop back to the next function. So this is what actually called us. So you can see, not Windows. This is the C Runtime Library. I don't know if I can get this to tell me where we are. There you go. execommon.inl is actually where we are, right? Again, this is just code that got inserted by the C Runtime Library into our project. We didn't ask for it, it's just there. We come back out of invoke main, and now we're, you know, still rocking. I don't know where we are here. Let's take a look. Common main SEH. SEH is structured exception handling. So this probably sets up the structured exception handling stack for us or something like this, right? But anyway, let's keep going. In fact, now we've got a valid stack, which is even better, so I can just walk right up it. SRT common main, that's what got called. And then here we finally are, right? So you can see here is our actual call pattern. This is actually where we came in. We then went to here. We then went to here. And then we went to the thing that dispatches to our win main. I know it's kind of nuts, right? So what we can expect is that actually this is the function that would actually be getting called, right? wwinmain crt startup is where we actually expect to enter. And if we take a look, we can search for that. And you can see that when we link, we actually have the ability to specify what function we want Windows to jump to first. And by default, it's going to be set to, you know, whichever one of these you can find, right? But we could tell it whatever we wanted. Rather than telling it what we want, we can just pick one of these and use them, and we'll get jumped to, right? So winmain crt startup will just work. If we just, you know, specify that, the linker will find it and call it, or we could specify entry and tell it where to call. Now, we kind of want to know what the function signature is to it, but it looks like it's nothing, right? There we go. Wait, why is this like crashy? I can't like... Okay. There we go. So what we want to do here is just find out, is there anything particularly weird going on with what it needs to get passed? And I don't really know, like I said, because I don't remember. But all we want to do is find out what this might take as parameters. Now, this looks like it doesn't take anything as parameters, right? It looks like it's not getting anything there. So in theory, what we should be able to do is actually just use this as a declaration directly. And if we do that, then we should be completely good to go here. So in here, if I say, all right, I previously had this, I'm not going to have this anymore. So basically all of these things are gone. What I'm going to have is this exact thing here. And I'm going to go ahead and get rid of that. So if this is my actual startup code, and I compile it now, what I will find is any place that I needed to use something there, you can see we had our instance there. I'm not going to have that that information, right? Because that was stuff the C Runtime Library had prepared and passed to me. But that's okay because actually, hey, if you're a Windows programmer, you actually know where to get this stuff. Instance is actually something that we can get directly by calling get module handle, for example. And so we can get our instance out just fine, right? No problem. Now, I don't actually I want it to just be WinMain CRT startup. That's all I really wanted there. I don't know why entry point must be defined as complaining here because this is our entry point. And so I'm not sure why it's mad at us about that. But again, one of the weird things is this is not what I expected the startup codes to look like signature-wise, to be honest with you. So that was a little bit weird. So I am kind of wondering if we've got that right. But I think we should be able to, let's see, msvc/entry. What's the difference between these two? Where is the function signature? I just want to see the function signature. What do you expect to have there? That's all I'm asking. No, I don't. I just want the definition of this. Can't you look? How do you search in just I like how Stack Overflow is like, I just want MSDN search. Does this work? Wow. What is it doing? Hello? I don't even want to know. Anyway, I just want to know what that function figure should be before I go any further, just to make sure that we've got it right. And unfortunately, I can't actually see. Like, I don't even know what this is supposed to be. It's like text they pasted in here or something. I don't even know. Anyway, let's see what it says. The entry options at entry point. It's not even text wrap. Like, what is this? What is going on, Microsoft? The function must be defined with the standard call calling convention. So that wasn't happening. Start with that. LP void start. So yeah, this is when creating a. Oh, that's a managed image. The parameters and return value depend on if the program is a console application or Windows application. It's recommended you let the linker set the entry point so the C Runtime Library is initially correctly and see, but it doesn't say what. It doesn't actually say what the, in classic fashion, it doesn't say what the entry point difference would be. Let me go ahead and look at subsystem and see if it somehow defines it there. So Windows application, does it say what the startup is? Native code, WinMain or WinMain is defined. For managed code, Windows is default. Yeah, none of this. This is all, but that's also, again, that's for if you haven't. Yeah, this is really annoying. This is really bad. The documentation for Windows used to be good, and now it's not. So I'm just curious here also, what would happen if we kept this function signature? Yeah, so all I'm really trying to do is to have it find this, right? I want it to be able to find this guy. Let's go ahead and move this inside an external C block. And try a couple more things. But what should have happened in that documentation, right, if the documentation were good, is that it would have told us what the function signature needs to be exactly. Like, here is what I'm going to look for. How that's not there, I don't know. It's a very basic thing, you know, a linker should tell you. And yet, we can't find it. So if we don't define this, it says entry point must be defined. So I'm not really sure. I really don't know what's going on there. But, I mean, I guess there's no reason we can't just tell it if it really wants it to be defined. We could just tell it what the entry point is. I mean, we could just say this. Right? And then see what it says. Oh, sorry. Oh, so did we not ever specify subsystem windows and it just wants us to? Maybe even though the default is supposed to be subsystem windows, maybe we have to say so? I don't know what to make of that. So there we go. I don't know. Do you think maybe now we could get rid of this line? I'm not sure. So I guess the subsystem windows kind of has to be there, even though it's supposed to be the default. Maybe like when you turn off the default lib stuff, it doesn't know that it needs to be the default anymore, and you have to put it there. Because now I can get this, I can put this back in there. I also don't know what the difference is here. So it looks like it doesn't matter what I ask for parameters there either, which is kind of interesting. Can I do this now? Because I assume that was our problem, was that just subsystem windows needs to be there for reasons that are not mentioned in the documentation, but there you go. Okay, so now we can see whether that works properly as well, because we don't know, we may have broken something critical, right? So we have to see if we can actually work, but you know, as you can see, we're running just fine now. All right. So now we've completely gotten rid of the C Runtime Library from our Win32 startup code, but it's still being linked into the game proper. So the game DLL still relies on something potentially from there. So what I want to do now is I finally want to get to the part that I was going to talk about probably for next weekend, but I wanted to, so this weekend we'll do the sampling stuff, but then for next weekend I think we want to do this. So if we take a look here, if I move the no default lib up into our other line as well, so now neither the game nor the Win32 layer will have the C Runtime Library, right? So they don't have it. Then you can see the problems that we end up with listed in the link line, just like before. Now, some of them are what we expect. So we don't have check stack or security cookie because remember, these are on the common line, so those will again get rid of that for us, right? So all the common linker stuff that gets rid of the stack problems still takes place. Memset and float used are problematic because, again, those were only in the Win32 part, but since we made a separate file for them, we can just take that and, again, make that be part of the build line. So I can put that on here and here and just link that stub in that defines those parts, and then we're good, right? So that's fine. Then we're only left with a few things, and you can see them right here. So now you know 100% what we actually use in the C Runtime Library. It's just 3 functions, right? Those are the only things we didn't implement ourselves, and they're the transcendental math functions. Sine, cosine, and atan. So if we want to get rid of the C Runtime Library, what we have to do is replace sine, cosine, and atan2. Once we have those, then we can literally be library free. Like, there will literally be no libraries used in Handmade Hero at all, not even the one the compiler tries to shove in there without your permission, which is pretty cool. But that is something that, again, like I said, we want to put off just a little bit, probably till next weekend. But other than that, it's all of the stuff has been removed. Now, we can, if we want to, take a look at what those functions do, right? If we go ahead and here we go. So in here we've got cos f, sin f, right? And atan2f. If I go to the definition of these here, you can see, hey, they didn't even bother implementing a non-double cosine. They just call their double version and then cast it down. You know, oh well. If we take a look at the definition of that one, we can check and see what that's actually doing. Looks like we should maybe be able to do another find in files. Or not. Let's see if I can find atan2. Am I looking in the right place? So it looks like the source for those maybe isn't in there. So I don't know. We can step in and see where we go, like I did before. But it may be that they just didn't provide the source. It's right there. What is the problem? Oh, uninitialized local variable. I don't care what the value is, but fine. Try 3. All right, so now if I step in here and we take a look at this, looks like it's not going to let us see it. So I'll go into disassembly. There we go. So you can see here that even though it didn't want to tell us about it, it is right there, right? So let's go in there, take a look. How many jumps does it take to get to the cosine code? So here's our cosine code, and as you can see, it's an absolute disaster. I mean, it's just nuts, right? So this again, you know, a lot of times people may ask why don't you link with the C Runtime Library? The answer is because of stuff like this, right? Like there's no way that you actually needed to go through all that preamble code. Like this is the actual code for cosine, right? And honestly, it's probably way too much code for cosine for our purposes, so we can probably get that down even more. But in order just to get here, we went through like 3 or 4 jumps or something. We just want that welded into our code directly, for starters. And we don't want it to do any of the error checking that it's normally going to do to look for like infinities or whatever, you know. stuff that it has to do because of the C runtime spec, but that we know we're never going to encounter. Like, we know we're always going to be passing it valid, reasonable values within a certain range, and so it can be optimized much more for that. So again, there really isn't anything in the C Runtime Library that I would ever call that I don't think has a bunch of cruft in it that I actually want to get rid of, which is why I don't like using it. So anyway, there you can see what happens with the cosine call. And again, we can get a better version by switching this to optimized, right? So it would get better than that, but it's still going to have problems in it, again, just due to the spec stuff there. And there's also, if you really want to use C Runtime, there's switches you can specify that tell it to use better versions, like don't worry about like float consistency or whatever, et cetera, et cetera. But even if all of that were true, even if we had a good inline cosine, we still wouldn't want to use it because we want to do our cosines 4 wide anyway. And the C Runtime Library is never going to do that because it only takes one float in and produces one float out, right? So, back to our regularly scheduled program. Why do I mention all of that? Well, because as we narrow in on our sampling here, we're probably going to want to start calling things like sines and cosines potentially, because we're probably going to want to do some things with our sampling that involve producing more regular patterns. And things like sine and cosine may be necessary to do that because like one of the ways we could produce a fairly regular pattern would be to have a hemisphere that we generate and use, you know, that we rotate potentially, which would require a sine and cosine at the head end, or who knows what, right? So it's hard to say. We don't know exactly what we're going to do here, but as we go forwards, we're getting to that point where we really would like our math library to be wide as necessary, and we want to stop using this stuff anyway. So that's where we're at. I'm going to remove the no default lib for the moment from here, like so. And then we're just going to go ahead and put that back in once we have those functions, because we're basically library free at this point. All we need to do is just that one little bit and we'll be good to go. All right. So that's all good, and it feels nice to kind of clean all that stuff out. And so hopefully we can finish those up maybe next weekend or do something like that relatively soon. Until then, I just want to go here and play around with the lighting sampling a little bit. So we've got our sample hemisphere function. Oh, well, actually, it's not a function anymore. It's just welded in, right? So when we compute our lighting in lighting test, there it is. So when we do compute light propagation, right, in here we set up the work functions. They get called into this function that's multi-threaded. And in here we create samples for our rays that are generated here, right? So you can see us creating random bilaterals and random deltas off those bilaterals for our rays. And what we want to do is we want to sort of work on this sampling pattern a little bit. Now, what we did to start working on this sampling pattern, if you remember, is we just made a little piece of test code that actually draws some sampling, right? And you can see that here doing its little dance. We're not using this yet. This sampling pattern is not getting used. It's just getting drawn. And so what we want to do here is we want to play around with this a little bit and get this to look like what we want it to look like, right? So pause for a moment. Let's go ahead and not look at that quite yet, and instead look at the thing that generates these hemisphere sample points, which I believe is down here somewhere. Right there. So this is the thing that's currently generating them. And, you know, we've got a bunch of cruft in here we can actually remove as well, because we don't care about it. Like, for example, the entropy counter we were using, we were playing around with that stuff. We're replacing the sampling now, so we can basically ditch all this as we go. So I'll do that first. So you can see here we do this random series. We don't really care about that anymore. The random series that's getting passed in here, we could just seed it once at the beginning if we want to, because we're not using stables. We're not going to use stable sampling anymore. We're still going to use randomness. So we don't really care about this. We can put this out here. We can also just use the entropy from the actual entropy solution itself. I don't remember what this is called, just called series. Like so, and then we can do the same thing we were doing before where we just place it back later. So this just returns us to pure randomness in our samples, and just gets rid of this stuff because we're going to replace it in a second, so we don't really need it hanging around in there, right? And the frame counter can go. I don't remember where that was. Oh, you know what? That brings up one more thing. Hold on one second. One thing you'll notice, we're running the game. And if you remember, we replaced that, we replaced the C Runtime Library startup with our startup. So I hit Alt F4 here. The app is still running, right? Why is the app still running? We hit Alt F4. Well, the reason the app is still running is because actually the C Runtime Library used to call exit process to actually close our process. We aren't calling that, which means that our app will just stay running forever in the background. No one will know. It'll be hidden and tiny, but it'll still be there. So what actually has to happen is inside the Win32 entry point now, because the C Runtime Library isn't calling exit process for us, we have to call exit process. But that's pretty simple, right? Not very difficult. It's going to tell us this return 0 is unreachable code. It's right, but you know, I don't really know why it does that because the function has to return a value. So I don't know. That's kind of weird that it does that. But yeah. I don't know what to say about that. It's a pretty unhelpful error message. So anyway, in here, now when I run my actual program and I hit Alt F4, it will exit out. Now I want to check really quickly that if we are in debug mode, it still realizes that that's unreachable code. And we'll see. Oh, you can see here actually, so in debug mode, we have ceilf and floorf are actually called as well. And the reason that you don't see those, I guess, in the optimized version is because it's actually put the intrinsics in for them so that they don't actually call out. So I think probably if I did that, we might be able to get it around that. I'm not sure. Looks like not. So that's another reason that we want to replace those with our own calls, because it looks like actually ceilf and floorf will want to do our own versions of so that we can compile in debug mode. Now I'm not sure exactly where those are getting called in the Win32 layer. It's in Handmade render, which is just in our rectangle drawing routine, right? So actually those, you know, we could replace those pretty trivially, and maybe we should, but you know, maybe we should leave them for, you know, seal and floor you can basically use with convert PS and various other things you can do in there that aren't too tricky. So, but we won't go down that rat hole now. I'll just continue to build with O2. Although the other thing I suppose we could do is in Handmade intrinsics, I'm just not sure if you could do this. like to force it to use it. But it doesn't look that way. It looks like it doesn't want to. Which is unfortunate, because I would like to, for now, be able to compile in debug mode and force it to do that. Oh well. It's all right. We'll replace it soon enough. So we need, and I can write this down. These are the 5 functions that we actually need. So that's what we will have to replace in order to run completely library free. Technically, CLF and FloorF we don't really need to replace because compiler can replace them. It's just in debug mode, it doesn't necessarily do it. So there is that. But they're so simple, we might as well just replace them because why not? And plus, we might want them to be 4 wide at some point. And that way, if we have our own versions, they would be 4 wide so that we can get SIMD support in there, which I think would be worth it, right? So I think that's good. What is this complaining about? How did we get a crash here? Access violation reading location. Tell me more. Oops. Is there a reason it's not showing me that? There we go. I'm like, I just want to see the instruction pointer, please. So it's looking to, so this is misleading, right? This is just because it's in release mode. It's telling us it's on this line, but it's not really on this line because this is a MOV that looks like it's doing something more substantial. I'm assuming this is talking about the, well, you know, maybe it's loading the 1. I'm not sure what exactly this is loading. Let's find out. So, oh, of course. It's so frustrating to try and use this debugger in release mode. It doesn't know any of the things that it itself did. So you can't ask it anything that you might want to know. Like, hey, what might have been here? Like, what did you put on the stack? Or what did you put in these off this base address or anything? It just never wants to tell you any hints because I think it just loses all the information when it creates the PDB for some reason. So it wouldn't be that hard to like track through here. It would just create a lot of data in the PDB, but I want you to do that. Like I don't care. Hard drive space is not expensive. Give me all of the information, please. So in here, I can't say I see I do want to see what's in XMM3. So it looks like to me that that this is actually a divide by 0 that's just not getting masked. My guess is that we need to set up the SIMD unit to not fault on divide by 0. However, what I don't understand is how it's managing to produce a value that looks like that. Because 1 over 1 plus distance squared, 1 plus distance squared, the distance squared would have to be negative in order for that to create a 0, right? So I don't really understand how that's possible. Oh, this is scalar code. What am I thinking? So this is not, never mind. This is not divide by 0. You can see it's a div SS. So it's not actually going to do these lanes. Never mind. We're good. So it really is this mauve. Somehow this mauve, we're like returning an invalid thing to iterate over in our lighting boxes, I guess. Let me try to hit that again. There we go. So somehow I wonder how many people on the chat figured this out already. The sharp people probably did. Probably one step ahead of me. I'll give you a second. I wish I had more coffee. We forgot one thing. This is not really an hour of shame because this is pretty tricky. So, if you remember, in order to get rid of the C Runtime Library, I said, oh, well, we're going to have to change the way the stack thing is because you don't want to use the stack check probe, blah, 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 right? Well, one sort of caveat to this is that the stack, right, is specified on our build line here, right? This is where we did that. That tells the Windows loader that our initial thread gets that much. It doesn't tell the Windows loader anything about subsequent threads, because subsequent threads don't go through the Windows loader, they go through us calling kernel 32 directly. So, what's actually happening here is when we get to a point where just a little more than 4K of stack space needs to get used. Let me trigger it again. If I can. Of course, now I can't. Well, I'm trying to, but I can't seem to trigger it. Anyway, when we get to a point where more than 4K of stack space needs to be used by the lighting functions, we were overflowing the stack is what was happening. Now, why was that happening? It's happening because inside Win32, inside the Win32 handmade calls, we create our worker threads, right? And here in our worker threads, you can see that's the only place we do it, right? That's the entirety of it. Let me jump to it in here. this is the place where the rest of our threads will have their stack set up inside the create thread call inside Win32. And one of the things that you have to look at is inside this create thread call, there's some stuff happening that suddenly becomes relevant when you are managing your own stack like we are. No results for create thread. Great. Good job, guys. Inside the create thread function, you can see there's a parameter called DW stack size. And what DW stack size is the initial size of the stack in bytes, right? So we were passing 0 here, which means that it uses the default size for the executable, which is specified in, who knows how it's specified, right? But here we go. The default size for the reserved initially committed stack memory is specified in the executable file header. Thread or fiber creation fails to run enough memory to reserve or commit the number of bytes registered. The default stack reservation size used by linker is 1 megabyte. Specifies the different default stack reservation size for all threads and fibers. Use the stack size statement in the module definition file. The operating system rounds up. Blah 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 blah. Right. So that right there is probably what we're seeing. Right. The initially committed stack size is probably still very low. So for whatever reason, I strongly suspect this minus stack doesn't alter the commit size for the thread. It probably still uses it for the reserve size. Maybe, I don't actually know. But I suspect that's exactly what's happening to us, right? So in here, in our create thread, we probably want to pass an actual megabyte value here so that we have plenty of room, right? For this function. Do we have a megabytes? Yeah. So if we pass 1 megabyte so that each of our worker threads has a nice big stack, I suspect that takes care of our problem. Unfortunately, we couldn't really get this problem to trigger 100% reliably. I thought it kind of was triggering reliably before. But hopefully it won't. So let's see here. So now what we should be able to do is set that stack size correctly. Now that I can get it to trigger, I wish I knew what I could do to get this trigger reliably. We can see whether that was actually the problem or not. So let's see what it was looking to address here. We can also see how big our stack actually was, right? Like how big of a stack we actually would need. Like I don't know what we create in terms of stack reservation for compute light propagation. Scrolling. Let's try that one more time. So I don't know what we might need in terms of stack space here. It doesn't seem like we would actually need that much. So it could be that I'm wrong about it. Because it's only going to enter into here. Let me double check that. Here's our thread proc. This won't require much stack, right? It's not doing anything fancy there. This one doesn't either, right? There's nothing weird on the stack here. I don't know how much that would necessarily put on the stack, but probably not very much. There's a fair bit of stack space getting taken up here, but a megabyte, it's just not very likely. So I may be wrong about this one, because if we have a megabyte of stack reserved, it should not cause a problem, I don't think. But I guess we'll find out. All right, so let's take a look at the actual code here and try to suss out what the problem is. There we go. So let's start by taking a look at some of our registers here. I don't know why. I think we just maybe haven't looked at the register windows in a while because they're not up. Let's put that. Ooh, no, don't do that. There we go. let me just go ahead and put these guys in here. SSE. That looks like everything we need for now. Oh, that's cool. All right. So if we take a look at what we're seeing here, you know, we've got, so you can see RSP, RIP is, this is where we are in the code, right? This is where we are in the stack. So we're using our BP to address, and that is a stack address for sure, right? Because, let's go back to the line here, RDX, this value here, is presumably an offset because it's pretty tiny, right? That's not a particularly large value. Our BX here is, you know, clearly a real base pointer. And you can see that it's basically a stack aligned value, right? Like this is the stack and here's RBP. So, you know, you can see just by looking at them, that's what's going on. And then this guy right here is a fixed offset amount, which is presumably the address of some, you know, constant we know or care about there. So what we don't really know here is if we were to start looking, do we run off the stack particularly early, or what exactly happens here? Let me see if I can pop this on here. I also don't know how this memory window would display basically memory that was illegal. How would you display? Okay, good. So, you know, this would be if we were going to hit a protected region. So as far as the access fault is concerned, this is what we should expect to see. So I'm going to go ahead and take a look at this region again, because I don't really know why it's looking there or what it's looking for. I don't have a lot of information about what it's trying to get. I'm going to go ahead and try to take that value and just see that on the stack. So there we go. I also need a little more room here. Let's just get a little bit bigger there. In fact, you know what? Maybe we'll move memory up to here, so because my head's kind of blocking part of it, and I might want to see. So again, we don't really know where we're looking here, or you know how we might get back to civilization. We suspect. We suspect that this is am I missing something here? Oh, I was looking at the wrong value. I was looking at RBP and I should have been looking at RBX. So RBX is not off the stack, right? This is stack. RBX is actually a real pointer that probably got allocated by somebody, right? Because you can see here, these are on the stack. For some reason, I was looking at RBP, not RBX. So this is not off the stack. This is actually going to be an address of something. We don't actually know what it is an address of. let's take a look at what solution is. 1FFC30. So it's actually this, it looks like, that it's trying to access, right? It's trying to access off of this solution points here. And so let me just take a look. It's using our BX as a base pointer, and you can see that that is the solution. So we're starting to piece it together here. This is RDX plus solution plus 18020H, right? That's what it's actually we've got so far. Now RDX, I'm guessing, is the hit point index value that it's talking about here, probably modified to have some kind of an offset baked into it, I'm guessing. So if you look at hit point index, well, I can't look at hit point index. But if we look at maybe how big a hit point actually is, so for example, size of lighting point, you can see that's 60. See here. I don't know how many hit points we've got. All right, so it's not that. Yeah. So if each one of those is size 60, the lighting points, I can't say why RDX would be so high. So what we would expect to see, so maybe it's not this line, maybe it's a different line that it's looking for there. Although, I mean, it looks really suspicious. So OX3C is 60, right? There's OX3C, right? For whatever reason, assembly language code uses H suffix for hex rather than OX. It's just a language convention. So you can see here, it's doing an IMUL into RDX. So RCX is hit point index. That's the hit point index, right? For sure. And so the hit point index is way out of bounds. It's totally wrong, right? Because we don't have that many hit points. So it looks like we've got a bug where we're returning a hit point index here that's just bogus. Because RDX is then becoming a value that's totally wrong. It's producing 60 times that, which is giving us the offset. So this line is happening here. This is correct. That is presumably the offset of the beginning of the points array. But this is garbage. It's just wrong. It's correctly multiplied by 60 to give you the stride. But that hit point index is almost certainly garbage. Right? So if we take a look at where that's coming from, again, I'm not sure why this would necessarily be something that's happening strangely after the changes we just made, because we weren't seeing this happen last time. So in theory, the much more likely culprit would have been something to do with the stack size or setting up the SSE. So it could be that we have an SSE setup difference that then creates this problem, which we'll find in a second. But at the moment, anyway, we do want to take a look and just see here, do we have some kind of problem with our hit point index that's causing this to occur, But anyway, so in here where we get the hit point index, what we do is we look to see whether or not we had a hit on a particular lane. And then the hit point index is just we loop through how many hit points there were for this particular surface index, right? And we just use the base pointer, the hit index, the base hit index. So unless the lighting boxes themselves were wrong, which maybe they are, it seems a little weird. I guess what we could see here is, let's take a look if we can, shouldn't have quite exited yet, see if we can find some of those other values. Again, just using sort of the laborious backtracing there. There we go. What I'd like to do is take a look at the hitbox information here. So here's where we are. The information I wanted to see was, this got unrolled. So the information I wanted to see was here. So this hitbox information. I don't know if I can still recover it, but I want to try. So if I ask for hitbox, unfortunately I can't get it directly. I don't know why it jumped back down there. Thanks. That not like I wanted to. Yeah, fantastic. So apparently every time I type into the watch window, it'll jump back down there. So I want to know if we can get this information out. I don't know if that's reasonable to do, because you can see when it pulls out the hitbox here, it goes into ECX, but then we overwrite ECX without having saved it. So you can see right here we kind of romp over it with other information. Probably because the hitbox doesn't really need to be used after that, I guess. It just uses offsets into it, like the light index, which is probably fine. So you can see here, this is trying to load out, I think, those base values. I don't know if they persist. They might. So we could take a look here and see what these are. Let's see if we can get some of those values. Why does it do that? Why would it ever think I wanted to jump back to the current line? That doesn't make any sense. I'm trying to read something here. So possibly that's, the value there. I want to look at R10D. Comp against 4. Oh, it's because this is probably an unrolled loop. So let's take a look at R10D as well. Is that actually still current? Hard to say. There's just a lot of code unrolled here. So, yeah. Not really. So, oops. So I wonder if we can figure out what box surface index was as well. So it looks like it came through in our CX originally. I wonder if there's any way to recover that. Ah, here we go. So this will help us quite a bit potentially. This is not really it. I don't think though. This may be some fake news. We'll find out. Well, box index looks valid enough, so that's good. So box surface index here is 0642. Now, 6 is not a valid box index, right? So if we look here at what hit, it says everybody hit. It says these are the box indices, and those are reasonable box indices. So if this is actually correctly the values, which again we don't know if it is, right? We're just guessing here. These would all be reasonable ray distances. You know, that could be. These would all be reasonable box indices. 2 of the rays hit box 333 and 2 of them hit box 321. These are all reasonable hit masks, which are all 1s, right? Basically. But that is not a reasonable box index. A box index of 6, the box index should be 0, 1, 2, 3, 4, or 5. 6 is totally not okay because a box index of 6 is off the end of the array. Now we have 1 off the end of the array, but it's used as a cap. So if this will look at 6 and 7, 7's not in the array. 6 is. Because you're supposed to look at 5 and 6 at maximum. So do we have a bug back here in our raycast that we just didn't know about that somehow we uncovered by doing our stack changes there? Do we somehow have a bug where this is producing the box surface index incorrectly? And I don't know. So here's some code where we produce the box surface index. The question is there a way for this code to produce a value of 6? So axis index at most can be 2. Yeah, this is totally busted. What did we do here? Did we accidentally flip these two? I feel like we may have accidentally flipped those two. Do you think? Maybe that's not actually true. Maybe our box surface indices are like weirder than this, right? Let's take a look. Because that would just be a straight up bug that we just didn't know we had. So if I go ahead and look at get box surface, so this code right here, I mean, I mean, you can see right, the way we're doing it is a little weird. But no, I guess that is correct. That's how we're doing it. So the axis index just gets shifted up 1 and then we OR in the positive. All right. So back to the question at hand, though. So if axis index if axis index is just shifted up by 1, then effectively what we're doing is we're just multiplying that value by 2. So if it can be 0, 1, or 2, then the maximum value that should be able to have is 4. If we OR in positive, then the maximum it should be able to have is 5, because positive is either 1 or 0, right? Now, maybe we're misunderstanding how that code will work. Maybe the less than 0 is somehow producing something other than that. And I'm not sure. So I'm just curious. Assert positive equals 0 or positive equals 1. And then maybe assert this is less than 6. Let's just see if we can fire either of these two asserts, because I don't know how else we're getting what we're getting without it. If that ray return value was to be believed, somehow a 6 got shoved in there, right? We don't know how, but it did. Now, unfortunately, as before, we don't have a 100% reliable way to trigger this, unfortunately. I will say this is awfully suspicious. I don't love the fact that I seem to not be able to trigger it once I put the asserts in. That's a little frightening. Way too soon to say we're hitting a compiler bug here, but there we go. Okay, like that was just a little unnerving. Okay, so we know that we're hitting this here. Suspiciously, we're getting a 6, and yet we have no idea how we would actually be producing a 6, because unless we've messed something else up, which we, maybe we have, in our arraycast function here, oh, that's the if zeroed case. That's the old one. Those asserts will get us nowhere. This is what we're looking at. Okay, so this is our actual box surface call, right? This is the different one that we were doing there. And this is just taking replicated 0s, 1s, 2s, 3s, 4s, and 5s, and placing them directly in here. Then it does a select on the box surface index. So the question is, what does it clear it to? It should be cleared. Well, I guess technically it doesn't have to clear it, because it's not going to return unless the lane actually got hit. It doesn't matter, right? So unless we're actually ORing in the hit mask, which we only do there, then the hit lanes should never trigger otherwise, right? So we only really need to care about it here. When we do our select for the box surface index, we're producing the box surface index here. So how on earth are we getting in a situation where we're getting a 6 out of things that can only OR in constants between 0 and 5? Because I'll be honest with you, I'm not sure how we would do that. Pretty bizarre. So let's take a look and see if I can put asserts in this part of the code, since I'm putting them in the wrong part of code before. I only... You know what I could also do here? So we do this. So if you hit this lane, trigger the assertion, just so it's a little easier for us to see. There we go. So if we hit that lane, I want to make sure that box surface index is actually within the valid range, 0 through 5. And it looks like normally it appears to be just fine. Lo and behold. So, what's going on? Can I access any of these variables? No, of course not. So, what is happening? All right, so we've got some building of this guy, right? XMM move. There's a lot of moving going on here. So here where we set box surface index up, you can see here we did our and not, and then our and our or. So it looks like XMM 0 was our box surface index. And if I go ahead and kind of take a try to expand it out, see what it says. You know, here's the values that it appears that it thinks it has, right? 5171. That's what it's getting. So this lane would be junk. Is that the lane that's actually triggered? And it is, right? So that box surface index to 7 is just totally garbage. So we must have written this code very poorly. That's my bad. I must have done something very stupid here that I just wasn't thinking through or something, right? Now, I don't really know what that would be because this isn't particularly complicated code, but I must just be thinking about it slightly wrong. Yeah, I don't know what. Or maybe when we mask it in, I don't know. But let's find out what the mask is, first of all. So we can determine this mask here. You can see what it must have been because we do a move, an and with this, then an and not, an and not with this, and then an and with this. Then we do an or to smush them together, right? So it must have come from XMM3 originally, the mask, right? Because we moved it in here, then we did the smoosh and the smoosh on 0 and 3, and then we OR them together for our final result. So the XMM3 register must have held back in some historical times, must have held the value of the mask. Now the question is, where did that come from, and can we still get a hold of it? Might have gotten destroyed, it might be gone. You can see that it's constantly being used here. So it looks like it's kind of been destroyed. Oops. However, the move mask of it may still be right. I don't know if the EAX ever got trashed here. It may have been. So unfortunately, I don't know how to really look at the mask for this particular time. However, I guess what I can do... So there is a way this could happen. If a box had no size. Right? If I assume I can't access these. Yeah. So if a box had the same min and max value, then two of those could be true at the same time, right? Debug info is just garbage. So I guess if I look at the disassembly here, I don't suspect I'll really be able to get much out of this, but we can try. Yeah. Let's see. REX, RDX. Yeah. So this box, anyway, would not have a tmin value and a tmax value that would be equivalent. Like, that's just not on the table. So if I look here when I'm actually doing the comparisons, here's the comp EQs here, right? 4 is obviously tmin because it's the same on all of them. And then the box maxes are like xmims 8, 10, 6, and 5. And 9. It looks like, because that's where the comp is going. But of course, you know what? Then they're going to get destroyed. But, you know, we can look and see what these actually were. I guess that would tell us the masks. So I don't, because, yeah, I just don't know how often these things were used again. A lot of these just got reused again, so that's not really going to help us. So the thing I want to know is whether the T-box, whether any of these can be true at the same time, right? Because if they were, that would give us the opportunity to create larger values. If you OR in, for example, let's say you took 4 and you ORed in 2, then you would get 6, right? If you got 1, 2, and 4 all ORed in together, then you could get 7. So this code presumes that the tmin cannot be hitting multiple boundaries at the same time. But actually, that's not necessarily the case, I suppose. Right? If it hit the corner just on, then in theory that would just work. So I think basically what we're seeing here is this just isn't a good way to do this, unfortunately, because although it's almost always correct, if you literally just hit the corner, like an edge of the box, then the tmin value could work out just right. So knowing which box we hit, which side, is more complicated. Also, what is the point of this? I mean, this is an AND with 0. What exactly do you think you're going to produce, right? I mean, that's just dumb. So we start out with 0, right? And then we want to select a box index by seeing which one of these things we hit. When we take this mask value, we almost have to keep like a running mask as we go to make sure we only ever use like one of them. So once a lane turns on, it kind of has to be turned off for all other ones. So I mean, I guess we really want something like this. So we start off with a BS mask value that says, okay, here's where ones go. Once something goes there, then the BS mask has to be updated with an and not, right? I think. Which we can make into one instruction, right? We can put an and not in here. But we're then saying like, all right, once we've masked any lane that came back true here, we cannot use for the next one. We have to mask it out. That seems right to me. So I'm going to try that and see how we do. So again, this then becomes an update of BS mask. And I think that should be okay. Now there's probably a cleverer way to do that. But like I said, we want this to be in, for starters at least, and not. Like so. And we already have that function, we just don't expose it. So inside the SIMD stuff, we have and not, you know? It's sitting right there, but we just don't have a way to actually access it. So we want to have a thing here that's like, so I don't really like the convention of having the not be the thing that it should be called not and or something if it's going the other way. So I feel like since the first parameter is the thing that gets knotted, I want mine to read the other way round, right? And if we look at the Intel Intrinsics guide, here, you can see that A is the thing that gets knotted. So it's really a not and, not an and not. So I think I'd rather write it that way. You know, just say, just so it's clear. So in here, we're going to do that not and all the way down, or and not, sorry, all the way down, like so. And I think that's what we need there. What is the problem? Oh, yeah, sorry. So now we should get the correct box index, I believe, in all cases, even cases where we have them not going, although obviously I'm wrong. Hold on a second. Get that out of here. We should be able to make that work now. I probably messed something up here. Oh, yeah. Yeah, this is not at all what I wanted to do. Sorry. So what I wanted to do is keep a running total of all the things we had masked in, and I didn't quite do that, right? I wanted BS mask to actually be the thing that gets ORed together, and I'm not actually doing that here, right? So it's not quite correct. This and not supposed to be here, not here, and I'll show you what I mean by that. So the BS mask has to be all the lanes that were ever true. So every time we do it, we have to take the new mask value that we were going to do, right? And we need to append it to the BS mask. There's a couple different ways we could do that. I'm trying to think of what the most efficient way to do it is, the most concise way of doing it in the code, right? But we need to keep the knockout values there. What was happening here is, you know, later you could turn a lane back on that, you know, a previous one, you're only doing just the immediate previous. And the immediate previous isn't sufficient, presumably, right? So let me make sure. Maybe I'm wrong about that, but let me just make sure here. So the first time we get BS mask here, what we're going to say is it's going to have true in the lanes where we could actually write, where tmin and tmax are, where tmin is equal to boxmax, right? We're going to OR in the one based on those lanes. Then what we're going to do is say, all right, we're going to knock out that lane, just those lanes that we used in the previous time, and prevent them from hitting. And then this will tell us which ones are there. Yeah, so you can see it loses this information then pretty much immediately, right? because now this might just be 0. Yeah, so this is not sufficient and not at all what we wanted. So let's try that one more time. So really what we want to do here, right, is we want to build this thing up piece by piece, right? So let's start with the mask building code. And the mask building code is pretty simple. It's just an OR. So as we go each time there, you can see this would build up the mask that is what is allowed in, essentially, right? I'm sorry, what has already been filled. So lanes that have already been filled are now have 1s in them at this point, right? And so what we need to do now is just actually remember what these mask values are. So what we can do here is say, you know, something like this. So maybe we'll call this the running mask. So probably it actually looks more like this. Oops. And again, there's probably a better way to do this that we could think about if we thought about it a little more carefully. I'm just going to do the basic version first. So the running mask just gets these things ORed together. And I'm going to pull this mask out like so. So there we have that written a little bit more succinctly there. So we start out with nothing in the running mask, and this mask is set to the first thing, right? And then each time we would update the running mask as such, right? Then when we need to actually write to our box surface index, each time out, so for example, our box surface index here, the first time it's just equal to 0. So we actually don't need to do anything for that. The next time what we need to do is say, okay, the box surface index, we will orient a 1, and we're going to AND that with this mask, but we also need to knock out anything that might have been in running mask, right? So the AND not actually goes here. Sorry. Here. Where we say this mask that we're going to OR in cannot have any lanes in it that were already handled. So that just continues down as we go. Like so. Oops. So we start off with 0. The running mask actually doesn't have to get updated in any particular way here. We can just start it out that way. So that's what was true the first time, right? So the first time we start out, we assume zeros everywhere, and we say, okay, if there's a 0 in a lane, it will remain there if the tmin equals the boxman, and we'll just consider that filled. Then we go and say, okay, now let's look at boxmax. Update with boxmax, but don't do that. Don't actually use anywhere that would have been knocked out by the running mask. Then update the running mask. Same thing again, same thing again, same thing again, same thing again. So now we keep that running tally. Now at the end, we don't really need this last one because the running mask doesn't need to be used for anything at the end, so the final one actually, it's not relevant, right? But otherwise it would have been. So I think that actually now correctly does the thing we want to do. We should probably step through it and look. We're out of time. But let me just check through the assertions here. Seems safe. Yeah, so I'm not seeing any really problematic stuff happen. So that should be good. So that code was just not really correct. And I'm not sure why we weren't having a problem with it before, but I guess we jiggled enough stuff with changing the C Runtime Library out that we were no longer getting the same amount of padding or something, where the stack was just getting messed with a little bit too much, or who knows what was happening there, right? So now what we can see is this code is, you know, probably quite a bit slower, unfortunately. But at least is now, I think, correct. And speed-wise, we didn't really take a hit for that, it doesn't look like. So that's kind of a good thing as well. So I guess it wasn't slower in a way that really affected our profile dramatically, which is kind of nice. So I'm going to go ahead and wrap up for now, and tomorrow we will finish changing the hemisphere sampling, and then we will have to, because I probably will want to use sine and cosine for that, then we will have to move on to the C Runtime Library replacement, which again is not super complicated. We just have to replace those math functions, but we have to do some talking about how to replace those math functions in order to do that. So let's go ahead and go to brief Q&A. Can we use 6 separate bits to represent hits with each box wall and then take the highest bit to determine which individual box we'll use? We definitely could. I'm not sure how we would necessarily get that bit pattern out, though. So you were suggesting using LZ count EPI 32. So let's take a look and see what the compatibility is on that. is this function? Dude, that's an AVX 512. We can't use that. It won't run on anything. I was gonna say, I'm like, well, you know, I pretty much always use just SSE2, so maybe it's in 4 or something. I just haven't looked. Because I was like, I've never used that function, and that's why. You know, but we still could do something like that where we process it after the fact. I mean, your idea is still valid because we haven't thought much about. We just kind of slammed this in when we needed it, right? We didn't think a lot about how we should do it. So it's worth thinking about that. What you're talking about, though, it's possible we could do something where we just OR in bits that don't overlap, and then later when we pull it out to do our access, then we could do it. So, for example, we could use bit scan in the exterior code, right? And pull it out that way. You know? So I feel like that would work. Return the original destination. What, just in memset? Are you talking about memset, or I don't know what you're talking about? Ginger Bill said, return the original destination. Oh, yeah. This is, the compiler's just calling this. We don't really need to. We could return 0 here and nothing would happen. But yeah, we don't want to leave a time bomb in there. If someone cut and pasted this code and then used it as a memset, they would be unhappy. So I agree, Ginger Bill. We shouldn't leave that like that. It's better to have it do the right thing in case anyone actually cares. I meant to return the original destination. I just didn't actually type that in. Let me see. Would it be better to make hemisphere sampling visualization an actual hemisphere with dots rendered on it? Yeah, probably, possibly. I don't know that we have any way to really render dots at the moment. I guess we can put little cubes down there. The other way we could do it is truncate those lines. So, for example, inside Handmade lighting, right? To make it a little easier to visualize in the way that you're talking about. What we could do is say something like this. So, you know, something that was a little potentially easier to visualize, like how you're saying, would be something more like this, right? And that way you don't have those like pin cushions in there, and you could, you know, we could shorten those up a bit. I don't know if we want to do push cube, but we could even do push cube. So in here, we could actually try that by putting a push cube in here and drawable cube. In order to do that, I'd have to basically do this. So we'll just call get current quads with, you know, however many of these we were going to do, something like this, and then in here we could just put on those cubes, I suppose. So we'd say, all right, group bitmap. Looks like it needs a bitmap ID for that. Well, I can just call this one. The position would be the start point plus the 1.0 times the normal. Radius of the cube, I don't know what that should be really. And then the color value. So in theory, I think that would probably work. I guess get current quads, we might not really need to call that, because the push cube function probably calls the quad function correctly anyway. In fact, I don't know, does the line segment one do? Yeah. So I'm not quite sure whether we actually need to make sure the space is reserved or not, but we can. So there's like the cube version, right? And the height value is a little misleading there, but that's because our cubes are kind of done in a weird way because they were made for floors originally, but there's like more what that's about. So that would be hemisphere sampling, where you could see it a little bit better in the hemisphere. And if we want to here, we can stop the series. So if we want to, you know, we can intentionally not use one that's changing, so we can see just our basic distribution statically. And so there you go, right? Now, since, you know, this is, again, this is picking completely randomly, you can see how it's not particularly well distributed, right? And that's what we were going to do today, but then we kind of got sidetracked on debugging in C Runtime Library, both of which are good. But what we want to do is we just want to even those out a little bit more. I wonder, could this be made a little lower? So you can see it a little bit better. So there you go. So what we want to do is we want to unclump this, right? We want to make this a little bit more evenly. And so that's what we're just going to do tomorrow, is just unclump it. That was it. We're not using this yet anyway, so we want to get it straightened out here, and then I'm going to move it into the code proper. So. Martins, why do you do star unsigned char star and @val instead of unsigned char val in memset? So there's no reason. If I think it through, so if I am calling unsigned char to truncate a value that was an integer, it should just work. But sometimes I force a reinterpretation. Like by default, if I'm not thinking about it hard, I always do the address version so that it won't do some weird signed operation that I don't want. Because even though I've programmed in C since I don't even want to know how long, like 20 years or something, I don't remember when I first started programming C. It's actually probably 30 years. Even though I've programmed C for probably something like 30 years, still I don't really have an internal model of its dumb sign extend stuff that it does, right? Because the intuitive way I would think about it is just not the way that C ever does it, ever, for me. So I tend to like overguard against having it ever do anything. If I could, I'd just tell it never do anything. Like, I'll tell you what to do, like, don't do it. But that's why you see me type that, is because I haven't thought about it at all, and I just don't want the compiler to do anything stupid, right? But in that case, you're truncating an int to an 8-bit value, so I don't think it will ever do anything strange. I think it will just take the bottom 8 bits always, I think. Off topic, what harm do you think could happen if you click on that yellow flag to upgrade MSVC? No breaking change has been introduced since this new machine, just lots of compiler upgrades. So generally speaking, if you have something that compiles your code okay, I never upgrade it until the end of a project. I had to switch versions of MSVC here because we moved machines, but normally I would never do that. You know, pretty much ever, right? Because a lot of times it just dies, right? It's like we upgrade it and it just doesn't compile our code anymore, or it like introduces a bunch of new errors we have to go look at, or it like, you know, who knows what it does, right? So why? It doesn't give me anything to upgrade it that I want. And also, pretty much every version of MSVC gets worse than the one before it, so it's not a good trend, right? So yeah, like, unless you have a reason to upgrade, you never upgrade. That's my policy. Unless you know exactly what you need and you're sure you're going to get it. And most of the time nowadays, it's all bad, right? Like, Windows gets worse every time it upgrades. So I would never upgrade it if I could avoid it, right? And in fact, I do avoid it on my work machines because they're not plugged into the internet, so they can't get to Microsoft to upgrade. Haha. But yeah, I never update anything if I can avoid it. Take everything off the net and never update it, and hey, you have a much better life. Because stuff's breaking all the time with these stupid updates that they don't debug and they don't test, right? And then you have to live with it. Filiadelsky, is the stack size set on the command line for the entire stack or for each stack frame? It's for the entire stack of a thread. So it's not for, like, if you have more than one thread, you get more than one stack, but each function doesn't get the whole 1 megabyte. Each function gets however much it needs out of the 1 megabyte. Martin says, another thing to mention when using /stack to get 1 megabyte stack for Spark programming is that all threads also will have the stack size by default. It could be an issue if somebody is creating and keeping hundreds of threads live. That's true. If you wanted to minimize the amount of memory you're using per thread, you would run into a problem there for sure. Although I would question why you were doing that, but, you know. Alex Kelbo, you once said that in your products you don't include Windows.h. How do we go about doing that? It's exactly the same as you saw me do with the OpenGL stuff. You just cut and paste the function prototype into your own code and then call getProcAddress to get the address of it out of the DLL. And then you don't need Windows.h. Right? Because Windows.h is just a giant collection of function prototypes and structs that you could just define yourself, the ones you need. So you don't need anything in Windows.h other than the exact stuff you call. So you can just copy it in and be done, which is what I do. I hope this is not too far off topic. Recently, I've thought about a hook-based execution memory management system where you allocate memory. You can tell it in the next line when it should be freed. There would be as many hooks as you like. For example, after frame hook level load hook or stuff like this, the hooks internally would be a collection of lambdas so they can capture the address that you want to free when the hooks run. What do you think of this idea? I don't like it. That's like how it was done in the witness, and I don't like it. The reason I don't like it is because if you know when memory is supposed to get freed, then you should be doing it in an arena, and you should have those arenas be tied to the things you're talking about. So for example, if you have memory that gets freed every frame, there should be a frame arena, and anytime you want to allocate something that gets freed at the end of the frame, you allocate it in the frame arena. If you want level load stuff to be freed, then you should be allocating it in the levels arena, and the level arena gets freed when the level goes away. The witness did this not exactly quite the same way you're talking about, but it had basically that where you'd basically hook stuff up where you'd say free this at like the end of the function or something, right? And I just don't like that, because if a function needs its own stack, then give it its own stack, its own memory arena, right? And if a frame needs it, then give it an arena. That's what arenas are for. And that way you don't have to track each memory piece individually, right? There's just no point to it. Just get the memory in a chunk for that. Just put all the memory together that goes with that thing, and then free the whole thing at once, so you're not looping through all these callbacks or God knows what else, right? What are your thoughts on using macros in C to make writing certain repeated patterns shorter, e.g. encapsulating extremely common patterns like pound define do fn for int I equals 0, I less than n, I plus plus f? I'm not averse to it. I think it's kind of too weak to be that practically useful. I prefer more strong metaprogramming than that, but I'm not averse to it. The problem I find with it, if you try to use it too much in practice, is that your ability to debug the code tends to go down, because debuggers oftentimes don't do a good job of stepping through macros. They typically won't really show you what you need to see. So as the macros you're talking about get more complicated, using the debugger becomes more difficult. So that is the thing I would say to watch out for there. But Clemensbaum, since you worked at Microsoft, would you recommend working at Microsoft nowadays for a new graduate? I guess what I would say about Microsoft is, like most places that you could work that are large companies, I think it's less a question about should you work at this company and more about where you would work in the company. I think Microsoft, Google, Facebook, you know, any of the places that grads probably look at these days, there probably are places in those companies that are good to work at, where there are smart people doing interesting things who will teach you something, and it'll be nice. The question is, can you find those places, right? So I think that's really the thing to focus on. It's not, should I work at Microsoft? It's, can I find a place in Microsoft where, you know, where it's not just a dingus festival, you know, and it's like there's actually smart people doing smart things. I mean, I bet the kernel team at Microsoft is an amazing place to start working after you get out of college, right? There's probably some really smart people there, and they're probably doing some interesting code. I don't know, maybe not, but I would guess, right? On the other hand, like, the team responsible for the Windows 8 start menu was probably like the worst place you could ever imagine going or something, right? It was probably about how to like line up the right XML code to load the right like thing. I don't know, right? So I think that generally that's my perspective on working at large companies, is it has very little to do with the company, and has way more to do with where you are. And I realize that's not helpful, because it'd be way better for me to say something like, yes, like go work at Google, don't work at Microsoft or something, because it makes it easier. But I don't think that's realistic. I don't think companies generally are good or bad unless they're very small. You know, a very small company that has 10 employees is probably good or bad, right, to work at. But a company that has over 1,000 employees, which all of these companies do, I really just don't think you can, I really don't think you can make that determination. I think every team at those companies is probably good or bad to work at. And what you have to do is figure out how you're going to suss out whether a team that you might work on is good or bad. But the good news is, and to put like a silver lining on that, I think what you could say is take a job at Microsoft if you get that offer, right? Or just take whatever the best offer is, whoever's paying you the most or whatever, right? If you get multiple offers coming out of after you graduate to work at one of these larger companies, take the best offer you can find and then try to move around, right? When you get there, try to sniff around, spend your time, your spare time, do your work during the day, whatever they want you to do it, and try to do it well so that you have a reasonable reputation. Sniff around and find out where those good people are. Find somebody you like and you trust, do the networking, and then try to move to that team. Think of your first 6 months or a year at whatever company you go to as you figuring out where to be in that company and then go there. Because it's very unlikely. I mean, maybe, it's possible. I said Twitter, I think, at one point, maybe, I don't know. It's possible that a company like Twitter literally has no people working at it that you would ever want to talk to or learn from, right? It's possible. But it's probably not possible at like Facebook, Google, Microsoft, any of the really big companies that have research, serious research teams. It's probably just not the case that you can't find some good teams there. There's going to be good teams there and good people on those teams. And so I would say that your perspective on should just be like, go there and look for that and then try to move there. Because when you first start working, your first job out of college anyway, there's going to be plenty of stuff you just need to get used to, like having a 9-to-5 job and not studying, stuff at night and stuff, right? Just getting used to like finding an apartment, like, your first 6 months to a year, you've got life things to deal with anyway. Trying to pay off school loans and, doing whatever. You've got all this stuff you're worrying about. So, don't worry too much if you're in a group that sucks, right? If you're in a bad position there, it's okay. It's your first job. It's not necessarily going to be your dream job anyway. It's fine. So just make the best of that, I would say, and then spend some time, get on those company aliases that are like research talks that people come and give, and when there are people presenting stuff internal to the company and all that stuff, get on those internal aliases, read them, see what looks interesting, go to those people, talk to them after their lecture, just make friends as best you can. Some people are good at that, some people are bad. If you're bad at making friends, I apologize. It makes it harder, right? Networking is a big deal. But try to make friends, try to find out where those things are, and then see if you can make some friends with managers and people who are in those departments and say, hey, can I come over and work there? How could I do that? I'm really interested in what you're doing. Trying to make that move happen. I think that can work out for you. Because again, there may be some companies that are just so lousy at what they do that there's literally nowhere there to work that you can learn from. And that may be true. But most of these companies, that's not true. So most of these companies are going to have groups in them that are good, and you just have to find them. And so that's, I think, the optimistic thing you should focus on is that, very few of these companies, once they reach a certain size, can get away with having literally nobody good, right? Like, there's going to be good teams there somewhere, right? And so you just got to focus on finding them. And you're going to be one of the only people doing that, right? Because most people like, thinking about, let me figure out how much XML I can generate in a day for this Windows Start menu. Most programmers today like that. So they're not looking they don't want to think about memory management, right? So you're not going to have to worry about everyone wanting to work in that group or anything. There's a small number of people who want to do serious work every day and want to learn, and if you're one of those people who prioritizes that, you should be able to make those friends, make those connections, get moved over within a few years. You're not going to have to spend 10 years working at Microsoft to find your way to a good group, I don't think, if you're putting in the effort to do so. If you just go there and do nothing, then no, you're going to end up in something where it's like XML all day or whatever, and that's just going to be your life, right? But if you're proactive, I think you can, in most of these companies, move. Because again, a lot of people aren't going to do that. And a lot of people are thinking more about career advancement and making more money, right? They want to get promoted or whatever else, right? Just don't worry about that part. Worry about how do I get to a good group, right? And then if you're not doing what they're doing, right? They're trying to be upwardly mobile. You're trying to be laterally mobile and get to a place where you can be happy and productive and be interested in your job and learn from those other people. So that's what I would say. And based on my time at Microsoft, I would say, yeah, I don't like what that company does. But there are good people at it, right? And so, you know, when you first start working there, do I want to work, you know, on the sorts of things that they tend to do? No, because I don't really like it and I don't approve of a lot of it, right? But as a first job or a place to go to learn things, are there places inside it where you can do that? Absolutely. And it may be less true today than it was then, because when I was an intern at Microsoft, the caliber of people there was way higher probably than it is now, just even as a function of its smaller size. Remember, the smaller the company is, the easier it is to have a high density of good people. When you get up to a huge number of people, it becomes a lot harder to have them all be good, right? And the ratio gets lower. But do I think they've somehow gotten to a place where there's literally nobody good there? No, I really don't think so. I think they're just, the good people are far outweighed by the people who really don't know what they're doing, but that's okay for a first job where you can learn. Just go hunt down those good people and they're there. Microsoft has a large research department too, so you know you can go do more theoretical things there too. If you can kind of sideways move into that somehow is another option too, right? Because they do a lot of research there, which is not the same as product development. So a lot of opportunities, and I would say that that's the thing to focus on. Figure out, you know, do a due diligence test first. Is the company I'm going to literally so bad that there's nobody good there and nothing to learn, right? That could be possible. It's not true of Microsoft, even today. I'm fairly certain, right? But, you know, maybe some other company, it really is that bad. Okay, maybe then try to avoid that job. But any of the other jobs, Google, Microsoft, Facebook, etc., I think they're big enough. They've got teams in them that know what they're doing somewhere. There are people there who know what they're doing. Find those people, try to work with them, and I think you'll be okay. Do we still need a separate translation unit for the MSV stuff? In my products, I had no problems having it in one unit. I remember there being some reason it has to be in a separate translation unit. Maybe for DLLs or something. I was having trouble. So I don't know. We can play with it later if we really want to, but I found that I had to keep it in a separate translation unit and it had to be C. And it wasn't so much that it had to be a separate translation, it's that it had to go through C. Now, it may be that that was only for Visual Studio 2012. It may be that's no longer the case, right? But that's what I recall. So that's all I can really tell you. And yeah, it sounds like Neil and is talking about asking like him, for example, of where to go in Facebook or whatever. So yeah, this is exactly the case. If you happen to know through like Handmade here or somewhere else, if you happen to know people who you trust, who work at these companies, who you know whose opinion you value, try to see if they'll help you. See if they'll help you figure out where to work, right? Because if you've got a friend at Facebook who you know has similar programming opinions to yours, then you can ask them, hey, do you happen to know where the places are in here that might be interesting to me, right? Where would you go? Where did you decide to work? Are you happy in the division you're in? If not, where would you go when you can? Are you going to try to move somewhere else? Where would that be, right? And so sometimes you can luck out and have a friend at Google, have a friend at Facebook, or maybe just someone online, like through the Handmade Hero community, like Handmade Network or something. Maybe you can find someone who already works there, right? So there you go. John Blow says, "You are so jealous that I get to go to GDC next week and see all the great talks." Yes, John, I of course am. Although, I think you have to put into perspective that as a new person in the game industry, you just don't really know. You don't have very much experience shipping games and understanding how to develop games, so you can benefit a lot from those advanced level GDC talks that you're going to go to that'll tell you all about the stuff you need to know. You know what I'm saying? So I feel like, yeah, you just have to bring your notebook, and make sure you take copious notes on things. Like, for example, you may not know, I do notice that in Braid and in the Witness, there were like no microtransactions. And so I feel like you've got a lot to learn about microtransactions, and I pretty much guarantee you there's going to be a lot of really great talks about that at the GDC, because, as you know from going to the GDC, games are not about making games, it's about making money, and microtransactions are a very good way to make money. All right, folks, I am going to close down the stream here, or I'm going to try to anyway. Let's go ahead and close this. By the way, I don't know if we can get this link into the annotation somehow, but again, just to remind everyone, this guide that Martin's made is just absolutely fantastic. So everything that we did about removing the C Runtime Library, you don't have to go back and watch my stream to figure it all out. He has already put it, everything we did, including the stuff that we were not looking online for, is all in here and very well documented. It's probably the best guide I've ever seen for this, and it's a guide I wish was around when I first was getting rid of the C Runtime Library, because it would have saved me a lot of headaches, actually. So I highly recommend this. Everyone should read it. It's very good. And anytime nowadays that I am doing this, and I don't even bother going to MSDN anymore, I just go right to his guide. It's that good. So definitely check that out. It's the best guide for this that I've ever seen. It's got everything in one place. It's great. All right. Thank you, everyone, for joining me for the next one of Handmade Hero. It's been a pleasure coding with you, as always. I will be back tomorrow, same time, same channel, when we will go ahead and do the thing that I want to do today, which I ended up deciding to get rid of the C Runtime Library instead. But I'll go ahead and do the distribution of points on the hemisphere thing, which was one of the last things I wanted to do there with our lighting sampling. So hope you join me for that. And then next week, we should also have a little fun doing the sine and cosine stuff that we wanted to do, so that should be fun too. So hope to see you back here either tomorrow or next week for that. Either way, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.